Okay, we have a question here. Aria is planning to invest in a new machine costing 150,000. The company anticipates that the machine will generate additional cash flows of 50,000 per year for the next 4 years. The discount rate for these cash flows is 10% per year. What is the present value of the expected cash flows from the machine over the next 4 years when it's been discounted semi-annually? All right. So the payment period and the discounting period are not the same. The payment period is after a year. The discounting period is semi-annual, so it's after 6 months. So we need to match the compounding period for the discount rate and the payment period. All right. So we're going to need to get the effective annual discount rate. Since it's not the interest rate, it's the discount rate. So the effective annual discount rate. Okay, this is your discount rate after a year, for a year, when you take into account compounding. Okay, so first things first, the discount rate is 10%. So we have to find the effective annual rate. So here it's going to be plus RI, which is our rate, 10% in decimal form is 0.1 over, since it's compounded semi-annually, so M, number of compoundings, is 2 to the power 2 minus 1. Okay, so 1, let's try from here because 1%. 1 plus 0.1 divided by 2, that is 0.05 to the power 2 minus 1. Okay, then you get 1.05 to the power 2 minus 1. You get 1.1025 minus 1. We get 0.1025, which is the same as 10.25%. Okay. So this is the discount rate for the year after we take into account compounding. Okay, so this is the discount rate we're going to use in our annuity formula. We've matched the compounding period for the discount rate with the payment period. Okay, I repeat again, we've matched the compounding period for the discount rate, okay, with the payment period, both 1 year, 1 year. So we substitute in our formula for the present value. Present value equals cash flow, which is 50,000 per year, multiplied by 1 minus 1 over, let's say, 1 plus our discount rate, 10.25%. So you put 0.1025. The power, the number of years, 4 years, the power 4 divided by 0.1025. So 50,000. I think we did this a similar one here. When we do this tabulation here, let's see, we did a similar one there. Yes. When we do this tabulation here, we got, what value did we get? Colleagues also answered, what value do we get when we do this tabulation here? So that we move a bit quicker. Don't start recalculating again. When we did this tabulation in green, I think you get a 3.6 something. Mr. Who was the one who was giving me answers earlier on? 3.1. Okay, 3.172, yes. When you do this whole tabulation here, okay, all of this here, you end up with 3.172. All right, then you say 50,000 times 3.172. You get 158,600 as the present value of the cash flows. So what we did again, we have matched the compounding period for the discount rate from a semi-annual basis to an annual basis, okay, which is 10.25. Once we matched the compounding period of the discount rate and the payment period, then we applied the present value formula. Part 2 says, how would the present value of Aria's investment change if the discount rate increased to 12% annually and had been discounted quarterly? So again, it's being discounted quarterly, so we have to match the compounding period for the discount rate with the payment period. So again, we use the effective annual discount rate, 1 plus 12%, 0.12. Since it's compounded quarterly, so M equals 4 to the power of 4 minus 1. So here we're going 0.12 divided by 4, I think you get 0.03. 0.03 to the power of 4 minus 1. 1.03 to the power of 4 minus 1. 1.03 to the power of 4. Let me get my calculator. 1.03 to the power of 4. 1.125 minus 1. It is 0.125, which gives us 12.5%. All right, 12.5%. So now we've matched the compounding of the discount rate with the payment period, okay? Because remember, the effective annual rate, it brings it to a year's rate after you take compounding into effect. So again, we're going to use this formula here. 50,000 multiplied by 1 minus 1 over 1 plus 0.125 to the power 4 over 0.125. Colleagues, when we do this tabulation here, I'm just feeling lazy to do this tabulation. I've talked so much, so that's why I'm skipping this tabulation. What did we get when we did this tabulation there? And please give an accurate figure, because there will be someone who will be studying alone. And if you give a wrong figure and they get the correct figure, you confuse the person who's doing the correct thing now. Then it's now me who has to start receiving the calls at night. Sir, I'm confused here. How do you do it? So when we do that tabulation, what do we get? Mr. Trywell, what did you get? Mr. Chanda, 3.006. 150, there's 50,000 times 3.00. Okay, 150,300. Yes, this is the present value. That's a wrong value, madam.